All right, so in example 2, we have 3 equations that we're dealing with. You can see, I'm going to label them, equation 1, 2, and 3. Okay. You can see that equation 1 and 3 have 3 variables, equation 2 has 2 variables. We do not know one of the values on the front end. We're not told like x equals 5 or like the last one z equals 2 or whatever it was. So here, our goal, again, like eventually what we want to get to is a single variable with a single equation. That's the whole idea. We can solve those. All right, but here we have 2 equations with 3 variables, 1 equation with 2 variables. So the part of the process that we're going to go through here is to try to create a 2x2 system. And when I say a 2x2 system, I mean 2 equations, and they both have variables. All right. So as I look at this, I already know for sure that I have an equation that has 2 variables, right? So I'm going to roll with that one. That's going to be one of my equations that I will use. Okay. So I'm just going to write that equation over here. I'm definitely using that one. Okay. Now what I need to do with the other 2 equations is create a combination between the 2, where when I create that combination, it actually are the only 2 variables that are left. So with these 2 equations, what I'm going to try to do is get z to go away. Because if I get z to go away, then we're just left with x and y, right? Okay. So the process here will be to eliminate we're going to eliminate z from equation 1 and equation 3. So in order to do that, we have to look at what both are equal, or how both are represented in each equation. So we have 3z here and 5z there. All right. So what is the least common multiple between 3 and 5? 15. So we want to make one of those z's become positive 15, and then in the other equation we want it to be negative 15. So there's 2 different ways we can do that. Let's say to make, with the equation 1, we want to make it become positive 15z, so we'll multiply equation 1 by 5. So the notation here, this is saying 5 times equation 1. All right, so I'm just writing that down for my reference. I know that I'm multiplying equation 1 by 5. Okay, so the result of that would be 5x minus 10y plus 15z equals 45. Make sure that you check as you go. You got to be really careful with this. A lot of different areas in which you can make simple arithmetic errors. We want to avoid those. So we made that z become 15. So the other one we want to become negative 15z. So we'll take equation 3, and to make this become negative 15z, we will multiply by negative 3. So that will become negative 6x plus 15y minus 15z equals 17 times negative 3, negative 51, negative 51. Okay. Make sure that you multiply all 4 values by that negative 3 and the positive 5 in the first one. A lot of times people forget to multiply by the value that you're multiplying through. Okay. So now we can create a combination, and the z should drop out. So if we just kind of add on down here, we have 5x minus 6x, that would be negative x. Negative 10y plus 15y would be plus 5y. And 45 minus 51 is negative 6. So now we have another equation that just have x and y in them, right? Okay. So we can take that equation and combine it with this one. And now work our way through this 2x2 system. All right. with this, you can either utilize substitution or elimination. It doesn't matter. Probably this one would be pretty easy to do what? Elimination. All right, you got negative x and negative x, correct? Okay. So you just need to multiply one of those equations through by what? -1. Okay. Another way to view it is you could just subtract the two equations, right? So if we multiply this equation through by -1, the resulting system, I'll just recopy it so we don't make any silly mistakes or try to avoid silly mistakes. So that would be your top equation, and the bottom one would become x minus 5y equals 6. So the result here, the x's drop out. When we combine those two together, we get negative 2y equals 10, or y equals -5. Oh, thank you. I totally recording, so making the correction. Good call. Nope, that's 2. There we go, 2. So y equals -1. Agree? All right, good catch. So we know for sure that y is -1. All right. Now, what we can do is take this -1, and the easiest thing to do is find the value of x. All right, and for which equation I would plug back into, I would probably choose this one because that one is given to us, and if we have a choice, using things that are given to us is generally better than like an equation we create. Okay, so with this, if we take this -1 into here, we have negative x plus 3 times -1 equals -4. So in that case, x will equal +1. So now we know x and y. Now we just need to find z. Doesn't matter which equation you plug it into. No, this has to be an equation that has z in it. So you could either plug it into equation 1 or equation 3. I'm going to plug it into 1. So if we take those two values and plug it into this equation here, we have 1 minus 2 times -1 plus 3z equals 9. Those two would combine to 1 plus 2 or 3, right? And if we move that 3 over, this side would be 6, so we'd have 3z equals 6, or z equals 2. Just like any system, you can take those 3 values now. This is saying it intersects at that unique triple. You can take those values of x and z, plug them into all 3 equations, and it should work for all 3.